Hey guys, this is JB from Planning Seeds Tutoring. In today's session, we're going to discuss quadratic equations. Don't forget to use my referral code JBMon20 to get 10% off your next tutoring package. So a quadratic equation is an equation that can be rearranged as ax squared plus bx plus c equals 0, where a cannot equal 0. Yes, this does mean that B and C can equal 0 if they need to be, and or C. So either or it could be together at the same time. But as long as A is not equal to 0, so A can be 1, -1, or any other value, as long as it's non-zero, it's fine. It would be a quadratic equation. So the quadratic equation itself can be solved by three common approaches. We have factoring, the quadratic formula, and completing the square. So when we solve for any equation, don't forget that we are trying to find the numerical value of the variable that makes the equation true. So in our case, we're using x as our variable, and we're trying to figure out what value of x makes it so that the constants a, b, c are still constants, makes it so that this equation right here does equal 0. All right, so let's start by working with the factoring method. So in the factoring method, we want to rearrange first of all, we want to rearrange the terms that we have to create the standard form. So let's say that our equation was written in a x squared plus c equals, let's say, bx. Negative bx. Well, if this is the case, then we would want to change it around so that we we transform this equation back to our original ax squared plus bx plus c equation, or that original form, which equals 0, and from there, which is the standard form. And after that, so first let's just do that. Ax squared plus bx plus c is equal to 0. All right, so after you set our equation into the standard form, we want to find factors of c. We want to find factors of c such that those factors would add up to being b. And eventually these would be what we call our factors. And using that, we can solve each of these factors by setting them equal to 0. So let's say we have two factors, let's say r and s. Let's say we have two factors, r and s. R and s. So when r and s are multiplied together, we get the value of c. And when r and s add up together, we get the value of b. Well, what this kind of says is, to solve for ax squared plus bx plus c, all we need to really do is, this only works actually if a is equal to 1. But we'll get to the situation where a is not equal to 1 or a is not equal to -1 in a little bit. But when a is equal to 1, all we need to really do is just find the value of c, where we have a value for r and a value for s, where they're two factors that multiply together to make c, and they add up together to find b. And these r and s values you can set as x plus r equals 0, and x minus r, or x plus s, is equal to 0. x plus s is equal to 0. And with this, we would be able to figure out what the values of, well, x is, just based off of this, since we would have already figured out the values of s, as there's r and s, because they're specific factors. And with that, we can figure out what the value of x itself is, because it would just be equal to negative r and negative s. All right. We're going to actually look into examples a little bit later. Next, we have the quadratic formula. So what the quadratic formula is, we can utilize the quadratic, we can also solve for the quadratic equation using the quadratic formula, which is where we set up the formula itself, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, 2 times a. And recall, I mean, this is from the same standard form that we already started off with. So this is the a from ax squared, and this is the b from bx, and this is the c from plus c. And with this, we have the value for x for these particular values of b or a, b, and c's. With this, we generally get two solutions, but it doesn't necessarily have to be two solutions. It's either 0, 1, or 2, but most often we tend to get two solutions. The way we can tell how many roots or how many solutions there are is by looking at the discriminant, which is this portion, the portion right underneath the square root. So what we call the discriminant. Or it's equal to just d. So whenever d is greater than 0, or if it's a positive number, then there's going to be two roots or two solutions. If d is equal to 0, then there's going to be one solution. And if d is less than 0, there's going to be 0 solutions, or at least 0 real solutions. This is when we're going to have complex or imaginary solutions. Remember, the reasoning as to why that would be is because if you have a negative number to be under the square root, well, there is no real number that you can take a square root of, which gets you another real number. It has to be an imaginary number itself. The square root of any number right here, any real number that's negative, is going to be an imaginary number. All right, so with this, we'd be able to figure out what the value of x is, or the solution itself. Finally, the third way that we can solve a quadratic equation is by using completing the square. So whenever we're solving using completing the square, we're trying to transform our standard form equation to a perfect square trinomial. So recall, a perfect square trinomial is one where the same factor squared. So let's say x plus, instead of using x and stuff, let's use this is just going to be an example. Y plus w squared is equal to y squared plus 2yw plus w squared. This is kind of like the overall formula for what the completing or the perfect square trinomial is. Perfect square trinomial. The generic formula is actually a plus b squared is equal to a squared plus 2ab plus b squared. Since we already used a and b for our generic quadratic equation, I just didn't want to use a and b again. We also have another formula called the difference of squares, which is when you have a plus, or actually let's go with the y and w again, or let's use new letters. U plus v times u minus v is equal to u squared minus v squared. And this is what we call the difference of squares. All right. Anyway, this part is not really necessary for the completing the square. For completing the square, all we need is to transform our quadratic equation into a perfect square trinomial. And with that, what we're trying to get is, when we're trying to actually complete the square, we're going to need to move the c value so that it would, so to make this perfect square trinomial, we would need to move the c value from the original standard form and to the other side, and then we'll need to add a term to both sides called b over 2 squared, and that would form a perfect square trinomial. That would kind of look like this. We would start off with an ax squared plus bx plus c is equal to 0. And then we move the c to the other side. So that's a subtraction of c. So let's get rid of that actually. That's going to be negative c here. And now we're going to add a new term called b over 2 squared. And that's exactly what it's equal to. It's going to be equal to b over 2 squared. So that's going to be whatever this value of b is. We divide it by 2, and then we square it. And whatever we do on one side, we have to do on the other side. So we have to just do the same thing right here. And with this, we would have a perfect square trinomial. And remember, a perfect square trinomial, it's in this particular form. So with that, we would kind of get that x, or this would equal just, we have to actually first divide off by a. So let's ignore that a value actually, but we're going to be getting a value such that it's equal to x plus b over 2 quantity squared is equal to negative c plus b over 2 squared. All right, so let's actually work on some examples which kind of showed up. So let's start off with x squared plus 4x minus 21. So in this problem, let's first do it with factoring. So when we factor, we want to figure out the major factors, the two factors of negative 21, which add up to being positive 4. All right, so what are some factors of negative 21? We have 1 and negative 21. We have negative 1 and 21. We also have 3 and negative 7, or maybe negative 3 and positive 7. And remember, we're trying to add up to getting to 4. Negative 3 plus 7, that equals 4. So with that, we kind of say x minus 3 times x plus 7 is equal to that, is equal to 0. And we get x minus 3 is equal to 0, x plus 7 is equal to 0, and x is equal to 3 and negative 7. Now, if we try solving it using the quadratic formula, we get x is equal to negative b, so negative b, which is negative 4, plus or minus square root of b squared. Well, in this case, b squared is equal to 4 squared, minus 4ac, which is equal to 4 times 1 times c, which is negative 21, all over 2 times a, which is 1. And this is just equal to negative 4 plus or minus square root of 16 minus, that's a negative 84, so 16 minus a negative 84, which is 100, all over 2. So negative 4 plus or minus square root of 100, well, that's just equal to square root of 10, or that's just equal to 10. So negative 4 plus 10 divided by 2, and negative 4 minus 10 divided by 2. Well, negative 4 plus 10 divided by 2, that's just equal to negative or positive 3. And negative 4 minus 10 divided by 2, that's equal to negative 7. Negative 14 divided by 2. On our next problem, we have the completing the square. So the next way that we would be approaching this problem is by completing the square. So we would have x squared plus 4x minus 21 is equal to 0. So if we move the 21 to the other side, we get x squared plus 4x is equal to 21. Well, now we're trying to complete the square right here. We're trying to make a perfect square trinomial. So what is b over 2 squared? Well, that would just be equal to 4 divided by 2, which is 2 squared. That's equal to 4. X squared plus 4x plus 4 is equal to 21 plus 4. And this just means that x plus 2 squared is equal to 21 plus 4. And that's 25. Let's take the square root of both sides. X plus 2 is equal to the plus or minus square root of 25. Remember, both the positive and the negative value square of the square root is going to multiply itself to get, or is going to square itself to get positive 25. And this would just mean that plus or minus 5 is equal to x plus 2. And that gets you x is equal to negative 5 plus 2 and positive 5. Or negative 5 minus 2 and negative 5 minus, or positive 5 minus 2. Which gets you a positive 3 and a negative 7. Which is exactly what we wanted. All right, let's do the next one. All right, so in this problem, we have x squared plus 8x plus 12 equals 0. So for factoring, well, what are the factors of 12? We have 3 and 4, 1 and 12, 6 and 2. Well, out of all of these, we can already see that 6 and 2 added to being 8. So we can kind of assume that this is equal to x plus 6 times x plus 2. Now with this, we have x plus 6 is equal to 0, x plus 6 is equal to 0, and x plus 2 is equal to 0. And so we get x is equal to negative 6 and negative 2. Next, if we look at the quadratic formula, we get x is equal to negative b plus or minus square root of b squared over b squared minus 4ac all over 2a. We get x is equal to negative b plus or minus square root of b squared minus 4ac times c, which is 12, all over 2a. All right, so 64 minus a 48. That's just equal to 16. So that's negative 8 plus or minus the square root of 16. Square root of 16 is equal to 4. So we get negative 8 plus or minus 4 divided by 2 is equal to x. Well, negative 8 plus 4, that's positive, or that's equal to negative 4, divided by 2 is equal to negative 2. And negative 8 minus 4 divided by 2, that's equal to negative 12 divided by 2, which is also negative 6. So x is equal to negative 6 and negative 2. And the next one, we're completing the square. Well, we have x squared plus 8x plus 12 is equal to 0. So let's move the 12 over to the other side. We get x squared plus 8x is equal to negative 12. Now let's add a value b over 2 squared. Well, b over 2 squared in this case would just be 4 squared, which is 16. And now we get 16 plus 12, or 16 plus negative 12, which is 4, is equal to x plus 4 squared. Now if x plus 4 squared is equal to 4, well, let's take the square root. Square root, we get plus or minus 2 is equal to x plus 4. Subtract that 4, subtract that 4, and you get a positive 2 minus 4, which is negative 2, and negative 2 minus 4, which is negative 6. So x is equal to negative 6 and negative 2. Thank you for taking the time to watch this video. I hope you have a good day.